You want to know a secret they don't teach you at dealerships? You want to know the real reason mechanics don't drive new trucks? I'll tell you. Every single day I walk into my shop, I see the same thing. New trucks, expensive trucks, trucks with more screens than a Best Buy showroom, and every single one of them is broken. Not broken like a blown head gasket. That's fixable, that's honest. Broken like a transmission warning light at 30,000 miles. Broken like an ABS module that costs $1,400 to replace and another $600 in dealer programming fees because you can't touch it yourself. Broken like a 2023 Ford F-150 with a 10-speed automatic that the owner bought brand new, babied it, changed the oil on schedule, and still found himself stranded on a highway in Wyoming because a torque converter clutch solenoid decided it was done. That truck has 28,000 miles on it. Meanwhile, you know what trucks I never see in my shop? The ones my guys actually drive. The ones mechanics actually keep. My lead tech has a 1999 Ford F-250 with the 7.3 Power Stroke diesel, 412,000 miles. He has never, not once, brought that truck into my bay for anything other than scheduled maintenance. My parts guy drives a 1972 Chevy C10 with a 350 small block that has never had a computer diagnosis, because there's no computer to diagnose. He fixes it himself in his driveway with hand tools and a Chilton manual. My transmission specialist, the best I've ever seen, drives a 2001 Silverado 2500 HD with the LB7 Duramax. That engine has 380,000 miles. He rebuilt the injectors himself for under $800. That same job on a 2024 equivalent, you're looking at $6,000 minimum, and half of that is because the dealer has to unlock the fuel calibration with proprietary software that you, as the owner, are not allowed to access. That's not an accident. That's a business model. I've been doing this for 22 years. I've seen every trend come and go. I've seen the good years and the bad years. And I'm telling you right now, the truck industry has never been in worse shape. Not in terms of the marketing, not in terms of the horsepower numbers they throw at you, not in terms of the chrome and the leather and the 12-inch touchscreen. In terms of what actually matters to a working man, durability, repairability, longevity, the ability to hand that truck to your son and have him hand it to his son, the industry has failed. Completely and totally failed. And the worst part? They know it. They built it that way. Today I'm going to walk you through 10 trucks that prove my point. 10 trucks that mechanics, real mechanics, guys who work on these things for a living, actually buy, actually keep, and actually pass down. 10 trucks that have more in common with each other than any of them have with anything rolling off a lot right now. And when I'm done, I want you to think hard about what you're driving and why. My name is Wade Tucker. I've been a diesel mechanic for 22 years and a wrench turner since before I could legally drive. I've worked on everything from mud-caked ranch trucks to high-dollar fleet diesels. I don't work for any manufacturer. I don't take sponsorships. I don't have a shop selling you parts. I just know trucks. If this is the kind of straight talk you've been looking for, hit subscribe and leave a comment below telling me what you're driving. Now let's get into it. Number 1, the Ford F-100, 1953 to 1966. You want to talk about the origin of the American pickup truck? You want to talk about where all of this started? Start here. The F-100 from this era isn't just a vehicle, it's an idea. The idea that a truck should be simple enough for one man to build, rebuild, and maintain without a dealer telling him what he can and can't do. These trucks ran flathead V8s and later the Y-block, which was not a perfect engine by any measure. The oiling issues on the early Y-block are well documented, but here's what matters. Every single problem that engine had can be diagnosed with your hands and your ears. No codes, no sensors, no throttle-by-wire calibration. You pull a valve cover and you see what's wrong. The body on these trucks was built like it meant something. Full-length box sills, thick cab steel, no lightweight aluminum body panels that crumple when your dog jumps off the tailgate. The frame is a simple ladder frame, 2 rails, cross members, a body on top. You can weld it, section it, repair it in a field with a portable welder and a piece of angle iron if you have to. I have seen these trucks repaired in ways that would make an engineer cry and then run for another 20 years without complaint. The aftermarket support for the F-100 of this era is extraordinary. There are companies that have done nothing but supply parts for these trucks for 50 years. Panels, floors, frames, glass, chrome, whatever you need. A 1953 F-100 is actually more repairable today than it was in 1970 because the community that surrounds it has spent decades solving every problem it ever had. That's the definition of a truck that has earned its legacy. Number 2, the Chevy C10, 1967 to 1972. I have strong opinions about trucks, and I have even stronger opinions about the 1967 to 1972 Chevy C10. This is arguably the most beautiful pickup truck ever built. I know that's a bold statement. I'll stand behind it. The body lines on these trucks are so clean, so confident, so absolutely right that they have never gone out of style. You see one parked on a street corner and every head turns. But looks are not why mechanics love them. Mechanics love them because of the powertrain. The small block Chevy engine, the 350, the 327, the 307, is the most well-understood internal combustion engine in the history of the American automobile. Every single problem it can have has been solved 100 times over. The rebuild kits are cheap. The machine shops know these engines better than they know their own names. The transmission options, the Turbo Hydromatic 350, the Muncie 4-speed, are equally well understood and equally well supported. You can rebuild a TH350 on a workbench in an afternoon for under $200 in parts if you know what you're doing. The chassis on the 1967-1972 C10 is simple, robust, and logical. There is nothing hidden. There is nothing proprietary. The suspension geometry, the steering, the braking, all of it can be sorted by a competent home mechanic with basic tools. I have watched guys with zero formal training successfully restore these trucks because the engineering is honest. It doesn't hide anything. Everything is where you expect it to be, doing what you expect it to do. That's not an accident. Engineers in that era were building trucks for people who worked them. They weren't building trucks to sell service contracts. Number 3, the Dodge Power Wagon, original generation. Let me tell you about a truck that was built for one reason and one reason only: to go places nothing else could go, and to do work nothing else could do. The original Dodge Power Wagon, introduced in 1945 based on military experience from World War II, is the most mechanically honest four-wheel drive truck ever built in America. Period. End of conversation. The Power Wagon ran a flathead 6. Not exciting, not fast, extraordinarily reliable. The engine in these trucks was designed to run in mud, in snow, in desert heat, in Arctic cold, at altitude, underwater to the running boards if the air intake was right. Military engineering left nothing to chance because in a military context, engine failure means people die. That mentality carried straight into the civilian Power Wagon, and it shows. The torque curve on the Flathead 6 was optimized for pulling and crawling, not for quarter-mile times or dyno bragging. It would pull stumps all day long at 2,000 RPM and never complain. The four-wheel drive system was a marvel of mechanical thinking. No push-button electronic engagement. No transfer case that requires a dealer scan tool to diagnose when the actuator fails. You pulled a lever and the front axle locked in. You pulled another lever and you were in low range. That was it. The front and rear Dana axles were heavy, strong, and serviceable with basic tools. There are Power Wagons working on ranches today that were built before your father was born. That is not hyperbole. That is Tuesday in rural Montana. Number 4, the International Harvester Scout. Here's one that a lot of people forget about, and that is a shame, because the International Harvester Scout was doing things in the 1960s and 1970s that the modern off-road industry has spent billions of dollars trying to replicate with electronics and algorithms. The Scout was a purpose-built off-road utility vehicle before that term existed as a marketing category. It was four-wheel drive, short wheelbase, solid axles front and rear, and designed from the ground up to be used hard and repaired in the field. International Harvester built truck engines. Not car engines, not crossover engines, truck engines. The 304, 345, and 392 V8s that powered the Scout are famous in the off-road community for their toughness and low-end torque. The 345 in particular was an engine that simply did not want to die. I've seen them with more than 250,000 miles still pulling strong, and I've seen them rebuilt in backyard shops with parts that cost less than a good dinner out. The architecture is simple, the tolerances are forgiving, the access is reasonable. The Scout also had something that modern trucks have completely abandoned, a design philosophy that assumed the owner would maintain and repair the vehicle themselves. The body panels were separate pieces. The interior was Spartan and functional. The electrical system, while not perfectly designed, was logical and traceable with a basic multimeter. When something failed, you could find it, fix it, and move on. You did not need a franchise dealership and a $400 an hour technician with proprietary software to tell you that your coolant temperature sensor had failed. You looked, you found, you fixed. Number 5. The Ford F-250 7.3 Power Stroke, 1999 to 2003. Now we get into territory I know personally and professionally better than almost anything else I can think of. The 7.3 Power Stroke diesel engine, made by International Navistar, installed in Ford Super Duty trucks from 1994 to 2003, is in my professional opinion the greatest diesel engine ever installed in an American light-duty pickup truck. I will argue this point with anyone, anywhere, anytime. Here is what makes the 7.3 different from everything that came after it. The fuel system operates mechanically. The injectors are hydraulically actuated. There is no high-pressure common rail system with 30,000 psi fuel pressure that will destroy an injector body if a single microscopic particle of contamination gets through. The engine management system exists. This isn't a carbureted truck, but it is relatively simple by modern standards and well documented by decades of enthusiast community knowledge. When a 7.3 breaks, you can almost always diagnose it without a dealer, and when you fix it, the fix lasts. The 1999 to 2003 trucks specifically hit a sweet spot in the evolution of the platform. Ford had worked out most of the teething issues of the earlier Super Duty series. The cab was bigger, the chassis was more refined, the creature comforts were adequate without being ridiculous. But the engineering priority was still function over feature. A farmer in 1999 could buy this truck, work it for 20 years, and hand it to his kid with a confident conscience. My lead tech, as I mentioned, has 412,000 miles on one. That is not unusual. The 7.3 Power Stroke community is full of 400,000-mile trucks that are still doing daily work. Show me a 2024 diesel that will have that conversation in 20 years. I'll wait. Number 6. The Chevy Silverado 2500 HD LB7 Duramax, 2001 to 2004. If the 7.3 Power Stroke is the king of Ford diesel history, then the LB7 Duramax is its counterpart on the GM side, and it is every bit as worthy of that conversation. The LB7, the first generation of the Duramax diesel built by D-Max Limited, a joint venture between GM and Isuzu, introduced something genuinely new to American trucks when it appeared in 2001. I know what some of you are thinking. The LB7 had injector problems. That is true. The early injector cups had a sealing issue that allowed combustion gases to contaminate the fuel, which destroyed injectors prematurely. This was a known problem, and it was addressed with a technical service bulletin that GM covered under warranty, and later became a well-understood and relatively affordable repair for the aftermarket. The key word there is relatively affordable and well understood. When you know exactly what problem an engine has and the parts and procedures to fix it are widely available, that is a solvable problem. That is not the same as a 2023 diesel with software issues that only the manufacturer can diagnose. Once the injector cups are addressed on an LB7, and at this point, if you're buying one, they should already be done, this engine is exceptionally robust. The block and head design are excellent. The rotating assembly is strong. The early Allison 1000 transmission that backed it is one of the best automatics ever made for a diesel application. My shop specialist truck, which I mentioned earlier, is proof. Nearly 400,000 miles and still pulling a 14,000-pound trailer without drama. That is what a real truck looks like. Number 7. The Toyota Hilux pre-2000. I'm going to say something that might surprise you coming from a man who has spent his career working on American iron. The pre-2000 Toyota Hilux is one of the most indestructible pickup trucks ever built by anyone, anywhere, for any purpose. I will stand behind that statement as firmly as I stand behind anything I've told you today. The evidence is not anecdotal. The Top Gear episode where they tried to destroy a Hilux is famous and entertaining, but it understates the point. The actual evidence is in every conflict zone, every remote mining operation, every disaster relief effort, every corner of the developing world where trucks have to work without the benefit of dealerships and service centers and computer diagnostic tools. The Hilux is there. The engineering philosophy behind the pre-2000 Hilux is very similar to what made American trucks great in the same era. Simple, proven components. The 22R engine, a 2.4-liter four-cylinder, is one of the most reliable internal combustion engines ever made. It does not make big power. It does not need to. It starts, it runs, it pulls, it does not stop. The timing chain is internal and well lubricated. The valve train is straightforward. The cooling system is appropriately sized. Nothing about this engine is clever, and that is a compliment. Clever brakes, simple lasts. For American mechanics, the parts availability on older Hilux trucks can be slightly more involved than domestic trucks, but the Toyota aftermarket is mature and well stocked. If you're willing to do a little homework, you will not be stranded for parts, and the labor to fix them when they need it is modest, because the engineering allows it to be. Number 8. The Dodge Ram Cummins 12-valve, 1989 to 1998. The 12-valve Cummins engine. I don't need to spend a lot of time convincing anyone in the diesel community that this engine belongs on this list, but for those who are newer to the conversation, let me give you the full picture. The 6BT Cummins, universally known as the 12-valve because of its 12-valve cylinder head configuration, is the closest thing to an indestructible diesel engine that has ever been sold to the American public. The reason is the fuel system. The 12-valve Cummins uses a Bosch P7100 mechanical injection pump. There are no electronics involved in metering fuel. None. The pump is entirely mechanical. It has been running since the late 1980s in agricultural and industrial applications all over the world. Farmers in countries where electronics go to die have been keeping P7100 equipped Cummins engines running for decades with nothing more than basic mechanical knowledge and access to hand tools. When the pump needs attention, you rebuild it. Dodge's integration of this engine in their first generation and second generation Ram trucks produced something that ranchers and contractors and working men across the country recognized immediately as a tool of rare quality. These trucks got bought, worked hard, and kept. I know a man who owns 3 of them, a 1994, a 1996, and a 1997, all with well over 300,000 miles. He runs them on his property. He services them himself. Not once has he needed to visit a dealership for anything other than buying parts over the counter. That is the 12-valve Cummins story in one paragraph. Number 9, the Ford Ranger pre-2012. Before Ford brought the Ranger back as a rebadged global platform in 2019, there was the original American Ranger, a compact truck built for the North American market from 1983 through 2011. I want to focus specifically on the pre-2012 trucks, and within that window, the most compelling era is probably 1995 through 2011, when the Ranger had matured into a properly refined package with well-understood powertrains. The 4-liter SOHC V6, which appeared in the late 1990s Ranger, is an engine I have a personal relationship with. I've worked on a lot of them. I've seen them at 200,000 miles running as clean as the day they left the factory. The design is conventional and logical. The ignition system is simple. The fuel system uses port injection, which is infinitely more serviceable than the direct injection systems common in modern engines, where carbon buildup on intake valves becomes a service item at 60,000 miles because there's no fuel washing the valves clean anymore. The Ranger also stayed compact when every other truck in the American market was growing. A pre-2012 Ranger will fit in a parking space. It will navigate a Forest Service road without anxiety. It will haul a cord of wood or a small trailer without complaint. It does not need a 5.0-liter V8 to do what a compact truck needs to do. The simplicity of the scale matters. Smaller truck means simpler engineering, means lower cost of ownership, means longer useful life. That formula has not changed, but the industry has completely abandoned it in favor of trucks that are profitable. Number 10. The GMC Sierra 1500 5.3 Vortec, 1999 to 2006. We close the list with the truck that probably represents the best value proposition in used truck history, and I mean that without qualification. The first generation GMT 800 GMC Sierra and Chevy Silverado, equipped with the 5.3-liter Vortec V8, built between 1999 and 2006, is the last era of American half-ton trucks where the powertrain engineering was prioritized over the electronics architecture, and the results speak for themselves. The LS-based 5.3-liter engine is the modern small block Chevy. It carries forward 60 years of accumulated engineering wisdom. The architecture is iron block, aluminum heads, a combination that balances strength and weight appropriately. The port fuel injection is clean and reliable. The engine management system is sophisticated enough to run efficiently, but simple enough that the enthusiast community fully understands every corner of it. When something goes wrong with a 5.3-liter LS engine, there are 10 forums, 6 YouTube channels, and 20 parts vendors ready to help you fix it for a reasonable amount of money without involving a dealership at all. The GMT 800 chassis, the frame, the suspension, the steering, was the last generation of GM truck architecture that felt like it was designed for working use first. The suspension geometry is straightforward. The components are heavy-duty without being unnecessarily exotic. The four-wheel drive system is reliable and well documented. I have seen these trucks with 350,000 miles doing exactly what they were bought to do 20 years ago. They don't ask for much. Regular oil changes, coolant flushes, brake maintenance. They ask you to take care of them and they take care of you. That is a truck. That is what this whole conversation is about. Now let me tell you why 2026 trucks fail. Because this isn't just about nostalgia. This isn't just an old mechanic complaining that things were better in his day. This is about a fundamental shift in the engineering philosophy behind trucks that has made them more profitable to manufacture and more profitable to service, at the direct expense of the people who buy them. The first problem is electronics. Modern trucks have between 70 and 150 individual electronic control modules. 70 to 150 separate computers, each one communicating with the others through a network architecture that was originally designed for industrial automation and has been adapted, imperfectly, for the demands of a vehicle that gets driven through mud, through water, through temperature extremes from -40 to 120 degrees. Each of those modules is a potential failure point. Each of those modules can fail in ways that strand you by the side of the road without any mechanical component in the truck being broken. Nothing in the engine, nothing in the transmission, nothing in the drivetrain has failed, but the truck will not run because a module that controls throttle input has lost communication with a module that monitors crankshaft position, and the system defaults to a safety mode that makes the truck undrivable. I have seen a 2022 Ram 1500 with 28,000 miles fail to start because the fuel pump control module had a software fault. The pump was physically fine. The fuel system was physically fine. The engine was physically fine. But the module told the truck not to start, and without a dealer scan tool running the most current software version, there was nothing to be done. The owner had the truck towed to a dealership, paid $180 for a diagnosis, and was told the module needed to be reflashed at a cost of $340. A software update for a module that never should have had the problem in the first place. Total cost, $520, a day of lost work, and a tow bill for software. The second problem is planned obsolescence. I want to be very careful here because I am going to say something that sounds conspiratorial, but is actually just business. Manufacturers have a financial interest in trucks breaking. Not catastrophically, that creates liability and destroys brand reputation, but regularly, predictably, and in ways that require dealer service. The old trucks I described earlier had lifespans measured in decades and hundreds of thousands of miles. The manufacturer made money on the original sale, and then the owner went to the aftermarket for everything else. That model produces loyal customers who tell their friends and sons to buy the same brand. It produces trucks that you still see working on roads 40 years later, which is the best advertisement any brand can have. The new model produces trucks with warranty plans, extended service contracts, software subscriptions. Yes, there are now manufacturers charging monthly fees for features that were free, and service intervals that must be performed at authorized facilities. The truck is not just a product. The truck is the beginning of a revenue relationship. Every service visit, every software update, every sensor replacement is a transaction. The truck becomes profitable not at the point of sale, but over its entire service life, as long as that service life is channeled through the manufacturer's network. The third problem is dealer lockouts. This one makes me angrier than anything else I will say today, and I have said some things. Right to repair. You've heard about it in the context of smartphones and computers. It applies to trucks too. Modern trucks have engine management systems, transmission control systems, and chassis systems that can only be fully accessed with manufacturer proprietary software, not third-party software that replicates the function, the actual proprietary tool that the manufacturer controls access to and charges for. If you have a problem with a system that requires recalibration after a repair, and many modern systems do, you have to go to the dealer. You have no other option. Your mechanic of 20 years cannot legally or practically access the calibration. Your local shop cannot do it. You go to the dealer, you pay the dealer rate, and if you complain about the cost, you are politely informed that it is what it is. I know mechanics, good mechanics, master technicians, who have stopped working on trucks newer than 2018 because the investment required to stay current with the proprietary diagnostic infrastructure is not sustainable for an independent shop. The manufacturers are deliberately engineering independent repair out of the equation. They are capturing the service revenue by making the service impossible to perform without their tools and their training, and every truck owner pays the price. The fourth problem is complexity for complexity's sake. I have customers who drive trucks with automatic parking systems, surround view camera systems, trailer brake controller systems integrated into the instrument cluster, lane departure warning systems, automatic emergency braking systems, and adaptive cruise control systems. All of that technology rides in a vehicle that they also use to haul gravel and back into fence posts. All of that technology adds weight, adds wiring, adds modules, adds failure points. And every single one of those systems can fail in a way that triggers a warning light that, depending on the failure mode, may or may not prevent the truck from operating normally. I am not against technology. A 2001 LB7 Duramax has technology. The 7.3 Power Stroke has technology. Technology that makes the truck work better is good technology. Technology that makes the truck more profitable to service while providing no measurable benefit to the working owner of that truck is not technology. It is a business strategy dressed up as a feature list. Here's where I land after 22 years of working on these machines. The trucks on this list are not perfect. They all have weaknesses. The Y-Block Ford has oiling issues. The LB7 has injector cup problems. The early Dodge Ram body panels rust if you look at them wrong. But every one of those weaknesses is documented, understood, and solvable by a competent person with access to basic tools and reasonable parts money. That is what a truck should be. A tool with known characteristics that a working man can understand, maintain, and repair for as long as he needs to use it. The 2026 truck market has some genuinely impressive engineering in it. The power numbers are real, the towing capacity numbers are real, the luxury features are real, but the durability trajectory, where these trucks are going to be in 15 years, how many of them are going to have 300,000 miles doing real work, is not a story that ends the same way as the trucks on this list. I see it every day. My bay is proof. If you're in the market for a truck right now and you want something you can actually own rather than rent from the manufacturer on a payment plan of both dollars and freedom, look at the list I just gave you. Buy one that's been maintained or learn to maintain it yourself. Get comfortable with a wrench. Get comfortable with a shop manual. Build a relationship with a mechanic who works on these things and knows them well. Because the truck that will carry you through the next 20 years is probably already built. It's already out there. It probably has some miles on it, and it probably doesn't have a screen that shows you a bird's eye view of your parking job. And it will be running long after every truck on the dealer lot today has been retired. I'm Wade Tucker. Leave a comment below. Tell me what you're driving and what it's got on the clock. I want to hear your stories. If you're watching this and you've got an old truck that just won't quit, tell me about it. If you've got a horror story about a new truck, tell me that too. And if this video is the kind of straight talk you've been looking for, hit subscribe. I'm not here to sell you anything. I'm just here to tell you what I know. Drive smart. Drive something worth driving.